Good morning, fifth grade. For science today, we are going to be on chapter 8, lesson 5, and your books can be open to page 246. That's where we're going to start for lesson 5. So, we have been looking a lot at the weather. Today, we're going to be looking more at climate and how that ties together with weather. We're going to begin reading on page 246. Weather and climate are not the same thing. The climate of an area does not change as often as the weather. The words weather and climate do not have the same definitions. Weather is made up of all the conditions in one place at a single moment. So I'm going to write that down. So weather is all the conditions in one place at a single moment. So right now I could say the weather is cold and sunny, and within an hour it could be warm and rainy. The weather can change very quickly. So we see right there, it even says weather changes very often. Climate is the average of weather conditions over a long time, usually 30 days. Climate includes things like the average amount of precipitation, the average temperature, and how much the temperature changes during the year. Climates do not change as much as the daily weather does. So just looking at our notes, climate is the average of the weather conditions over a long time. And they said usually 30 years. Climates do not change much on a daily basis. So you won't see the climate change on a daily basis. It's over a long period of time that we normally see that climate change. We're going to look at how landforms, so such as specifically mountains, are going to affect the climate. Mountain ranges have different climates than areas around them. Higher land is cooler because temperature decreases with height in the troposphere. But that is not the only way that climate varies around mountains. So right away, I do want to note that higher land is cooler. Just as an example of that, so I grew up in Colorado. So we one time went to Pikes Peak during the summertime, and in the morning, in the summertime, at the bottom of the mountain, I was in shorts and a t-shirt because it was warm, felt comfortable in that, and we got to the top of Pikes Peak, and I put on sweats and a winter jacket because it was that much colder as you went up 14,000 feet. There was actually snow at the top of the mountain during the summertime because it's that much colder. We're going to continue reading in the second paragraph. Areas on opposite sides of a mountain range can have very different climates. For example, the west side of the Cascade Mountains in the western United States has a wet climate. It can get more than 2.5 meters of precipitation each year. Temperate rainforests grow on this side of the mountain. But the area east of the mountains has a dry climate, like a desert. This happens because the air does not have much moisture on it by the time it reaches the east side. So it's a little bit broken up in your book, but you can see the two sides. So on this side of the mountain, it's got the water over here, and there's moisture on this whole side, which is where you get to see a lot of this grass growing. You might see forests, a lot of trees, and then by the time it goes up, it cools off and goes over. And this side, it looks a lot more like a desert. So the air's drier and it's warmer. So you see that as you go to the different sides of mountains, it can change very quickly. So on our notes, we're going to say that opposite sides of a mountain range can have different climates. Not only can mountains affect climate, but also oceans can affect climate. Oceans can affect a climate by slowing the rise and fall of air temperature. And we'll get that down in our notes right away. So, oceans can affect a climate by slowing the rise and fall of the air temperature. Remember that bodies of water become warm and cool more slowly than land. Because of this, the temperature of the air near an ocean does not change as quickly as air inland. In the winter, ocean beaches often do not get as cold as areas just a few miles inland. In the summer, the air over ocean beaches is often cooler than areas over inland. So this can be something that we don't get affected by as much because we don't live near an ocean. So we don't get to see this impact as much. Ocean currents can make a climate warmer or cooler. So we'll put that in our notes right away. Ocean currents can make a climate warmer or cooler. The Gulf Stream and the North Atlantic Drift are large currents that carry warm water northward. The water warms the winds above it. These winds make northern Europe's climate much warmer than it would be otherwise. A change in these currents could change the climate of Europe. On the other hand, cold currents that flow from Alaska to California make that coastal climate cooler. So it just affects, it's not anything that affects us personally living far from the ocean, but it's also nothing we can control. It's just how the currents and the winds work to make different climates either change or stay the same from year to year. Past climates. Climates are weather patterns over many years, but climates can change. In the 1600s, the climates of North America, which is where the United States is, and Europe were much colder and wetter than they are now. The time is known as the Little Ice Age. Many written records of the weather during this time still exist. Researchers can find clues about climate changes even before people wrote about them. For example, during major ice ages, huge glaciers moved across continents. They moved soil and rock of every size to form hills and lakes. Researchers can tell how the glaciers moved by making maps of these hills and lakes. Climates have changed many times throughout history, sometimes quickly, but usually slowly. And that's what's going to be really important, is that climates can change, but it's usually a slow process. It's not going to be overnight. You're going to see it in long periods of time. Looking at fossils is one way that scientists try to learn about climates in times before written records. Scientists assume that if an ancient plant looks very much like a modern plant, the two plants need the same kind of climate. For example, suppose that a scientist working in a desert finds a fossil that looks like a fern. Since modern ferns do not survive in the desert, the fossil would be a clue that the area was once more wet than it is today. The same kind of comparison is done with fossils of animals and other organisms. So scientists are constantly looking at land to see how it's changed, and if they can have any clues that help them see how it's changed. This last section talks about how climates change because we just read that they absolutely do change, but what's the reason for that? There are many events that might cool a climate. The Little Ice Age may have occurred because the sun produced less energy. Volcanic eruptions and asteroid or meteorite impacts may have quickly caused cooler climates in the distant past. They could have done this by putting dust and other materials into the upper atmosphere. These materials can cool the climate by blocking sunlight or reflecting sunlight back into space. So one thing that can happen, so those volcanic eruptions and asteroid or meteorites, so those are things that are from space. Impacts, and they can cause cooler temperatures. And that's something we see that they kind of block the warmer air from coming in. We're going to then look at ways that there can be warmer temperatures. Carbon dioxide, methane, and water vapor can also make climates warmer. So carbon dioxide and methane are both gases that would be in the air, along with water vapor, which we know is an invisible gas, can all cause warmer temperatures. They can be produced by human activities such as burning coal and gasoline. These gases can also enter the atmosphere naturally, such as through decaying matter, forest fires, volcanoes, and the water cycle. Many different events help to form a climate. Because of this, it is hard to determine why a climate has changed. Scientists have had debates on these changes and will probably have more in the future. So, scientists debate on why the climate changes. So, although there's a lot of reasons why the climate can change, scientists don't always agree on that, and there's so many more reasons why the climate changes that's beyond this that we see today. So that's something that's become a huge thing for our country is climate change and how we can better take care of the environment so that we can kind of minimize that climate change. And scientists are still debating that today. So your note should be completed, and then we're going to jump to our worksheet. Make sure that your name is on there. Weather and climate, make sure that you see that word that should help you out is average. And then as far as this goes, I want you to do those on your own, but we will look at number 9 together. It says, how have scientists been able to describe past climates? So in our notes, we just talked about how they can change, but it's usually slowly. So we can look in our notes to kind of help us out. So scientists look at maps, they look at fossils, they look at just different soils and hills. But I think the two biggest things that I see that researchers look at is they look at maps, and then they also look at fossils to help them decide. And that's how then they describe them also. So scientists Describe past climates. By looking at fossils and comparing old maps. And they compare those old maps to what they see today. Are those maps still accurate? Like if they see a mountain that used to be there and it's not there anymore, it could say something about what was happening as far as the climate goes. So number 9 should be done for you, and then what I want you to do is the first two and then completing each sentence on that one. We will do number 6 together with the Gulf Stream because this one's a little bit weird. So the Gulf Stream, the water warms the wind above it, so the Gulf Stream warms the air above it. All right, so you've got those last ones to do on your own, and then you're going to be all set for today.